Why don't you tell us what one-to-one means?
Okay, so a function is one-to-one if, let's say you have an element in its domain and it maps to some element in its range. It's one-to-one if only one element from the domain maps to each unique element of the range. So in order to maybe formalize this in mathematical terms, why don't I write that out kind of as an equation?
Please do.
Let's say we have a function, and let's say we're going from A to B.
From some set A to some set B.
Yes.
Okay.
So A could be like natural numbers or real numbers or something like that.
Or it could be, say, the set of trucks that are on sale at a certain auto dealer. Okay. Or the set of colors in the rainbow. Okay.
Exactly.
Right.
We won't use colors in the rainbow here.
That's okay.
I don't know the math behind that. But,
that's okay.
Okay. So let's say we have F from A to B. Okay. And let's say we've got let's say X and Y, sorry, are elements of A.
Yeah.
So X and Y, they're in A.
Yeah.
Okay. So let's take those and put them into the function. So let's say we have f of x, the function applied to x.
Yeah.
And let's say we know that f of x equals f of y.
Okay.
Okay. If a function is one-to-one, it's defined as when f of x equals f of y, you know for sure, or this implies that x equals y. Or, and some people like this definition a little bit more, or if, let's say, x does not equal y,
okay,
f of x does not equal f of y.
And could you just write one-to-one on the left here, just to signify that this is the definition of one-to-one? Okay, so we're going to try to articulate this in plain English here. So suppose that this is the image of the function.
Yeah.
So this is the image right here of the image of y of f, the function f.
Yep.
Okay. So suppose that I have these are the elements in the image of f.
Yep.
So you're saying for every element in the image here, it must have come from. So this is the domain.
Yep.
Domain of f.
Yep.
So I think in plain English, what you're saying is, every element of the image of f must have come from one and only one element in the domain of f.
There's a uniqueness to it, right? So there's a unique element kind of in each set. So if you have the function, maps to some element, well, it's only going to go back to one element in the domain.
Right.
It's not going to it's not going to here as well.
Right.
It's not going to there as well.
Right. Okay. Now, I think it's important to point out here that it is entirely possible that some element in the image of f is not mapped by some element.
Oh yeah.
Right. If from it's entirely this could be our function. Actually, we want this to be one-to-one. Okay. So we want this.
Right.
So here's here's the domain, and here's the image. Okay. So let's say I have another element here that maps to this.
Yeah.
Okay. But this element here is orphaned. There's no connection between between this element and any element here.
Yeah.
This is still a one-to-one function.
Oh yeah, it's still one-to-one.
Right.
Well, look at the definition, right? Like this has nothing really to do with making sure every element in the image has something in the domain related to it.
Right.
It's strictly when you have, an element in the image and you have two elements in the domain. If the element in the image is the same, it's got to be the same element in the domain. That's what it's talking. We're not talking about what you were referring to.
Right. Okay.